Unlocking Intelligence, a look at advanced DRL algorithms. What's up, everybody? It's your boy, Prof. RJ, and today we're diving into the world of deep reinforcement learning, or DRL. We're talking about giving machines the power to learn and make decisions like us humans, but way better. Over the next few minutes, we'll break down 5 powerful DRL algorithms: PPO, TRPO, DDPG, TD3, and SAC. So buckle up, smash that like button, and get ready to level up your AI knowledge. Proximal Policy Optimization, PPO, the stable genius of DRL. First up, let's talk about PPO, Proximal Policy Optimization. Imagine you're teaching a robot dog to fetch. PPO is like that patient trainer encouraging small incremental improvements. It uses a clipped objective function to keep learning steps manageable, preventing catastrophic moments. PPO strikes a balance between exploration and exploitation, achieving that sweet spot for learning quickly and finding the best solutions. Whether you're training a robot arm or optimizing a stock trading bot, PPO has got your back. Trust Region Policy Optimization, TRPO, the cautious climber. Next up is TRPO, Trust Region Policy Optimization, the cautious older sibling of PPO. TRPO carefully controls policy updates, ensuring steady improvement without drastic leaps. It uses a KL divergence constraint as a safety net, making progress with smaller, deliberate steps. Deep Deterministic Policy Gradient, DDPG, the smooth operator of continuous control. Let's talk about continuous action spaces, where actions are smooth, continuous values. DDPG, or Deep Deterministic Policy Gradient, excels here. It uses an actor-critic architecture, with the actor performing actions and the critic evaluating them. DDPG handles continuous action spaces effectively, controlling robots and optimizing complex systems. Twin-delayed Deep Deterministic Policy Gradient, TD3, the overestimation slayer. Building on DDPG, we have TD3, Twin-delayed Deep Deterministic Policy Gradient. TD3 addresses DDPG's overestimation issue with twin queue networks for more accurate evaluations. It also introduces delayed policy updates for enhanced stability. TD3 ensures smoother, more reliable learning, avoiding unnecessary missteps. Soft actor-critic, SAC, the master of exploration. Last but not least, we have SAC, soft actor-critic, the rock star of DRL for continuous control tasks. SAC is the ultimate explorer, seeking new solutions through a maximum entropy framework. It balances exploration and exploitation, making it robust and adaptable. SAC tackles complex real-world problems, pushing the boundaries of DRL. Level up your DRL game choosing the right algorithm. So there you have it, a crash course on 5 cutting-edge DRL algorithms. Each algorithm has unique strengths suited for different problems. When choosing the right tool, consider your task's requirements: stability, efficiency, or exploration. Dive into some code, experiment, and see these algorithms in action. Hit subscribe and share this video with fellow AI enthusiasts. Until next time, keep learning and exploring.